Thanks everyone for joining. So we're going to do a quick talk about Composable Polyglot Composition with WASIp3. And if I say we, that's my colleague Karthik, and my name is Thorsten, so we both work at Fermyon. And without further ado, I hand over to Karthik so that he can give you a demo.
OK, so let's imagine a situation where we have a Slack channel called Earling, where every message has to be uppercased. So we decide to build a service that takes any incoming message and uppercases it and returns it back. So that's the scenario we have. And let's say I built a Python app for it. Here we have a simple Python app, which reads the incoming body as a stream. And then as we get the byte stream, we take it and we uppercase the body and return it back. It's a fairly simple and straightforward app that we have here. So we can see the code here, and when we get each part of the stream, we call the pipe uppercase function, which basically uppercases the incoming body. So, and if I decide to run this, like I'm just going to, or before I run it, I can show you, like I'm going to use spin, which is in the CNCF. And so basically, I'm saying, let's just run the logic.wasm, which is the business logic here in the Python.
OK, so you have that running already in the other terminal, I guess?
I do. Yep.
There you go. Cool. So now you swap over, and you basically hit that endpoint, right?
Yep. I am running the app, and then.
Nope. OK. So you're sending a curl request to 3000 where the app is exposed, and you're sending some random text there?
Yeah. I'm just sending a random text, and I can even open the text file. So it's just a random generated text. And when we go back on the output, wow, my terminal's messed up. We can see that we get an uppercase text back. Now, we have a business logic working. But now what we have realized is we have a lot of people yelling, and we have a lot of messages going through the channel. So we are using a lot of network bandwidth. How do we solve it? Oh, and we come up with the idea, let's use compression so that we can save on some bytes. And then we first straight try sending compressed data.
Can you
yeah.
No, push it. There you go.
Yep. And then I said content encoding. Oh, and it doesn't work. And I go back and look at the logs. The app doesn't like that. I've sent compressed data, and the Python business logic is trying to read it as a UTF-8 string. So how do I solve this? This is where P3 works pretty well. And so we decided, let's write a compression middleware in Rust so that we have high performance. And we want to also use it transparently. Like, we don't want to change the business logic at all, so that we can write the middleware once and then use it with multiple business logics, like wherever we want to apply compression.
So to clarify that, that's one component that could do compression and decompression depending on which function you invoke, right?
Yes. Basically, like, so we have written a Rust component which basically looks at two headers. One is the content encoding, and if it's that set, it decompresses the incoming data before shipping it to the business logic. And if you have accept encoding deflate, then compresses the data on the way back out. So we have the Rust function, and so we can look at how we are composing. Like, we use WASM tools, and we say, take the middleware and the logic.wasm, which is the business logic in Python, and compose them together and give us a compose.wasm. So, and then we can just run a build.
Oh, I think you have to go to the application manifest. And yep.
Oh.
Nope.
And
all right, so right now you're basically pointing to the composed application instead of just the business logic. Then you're upping it, so the app will again be exposed to localhost port 3000 by default.
Yeah.
And yeah, you're sending compressed data there, I guess.
And it did not work.
It did not work, great. You had one job.
I know. Did I know?
Did you save the?
Yep.
Yep. Just try it one more time.
Now I think I broke the Rust compression app.
So this is what Ralph explained with 2 minutes on stage if something does not work out as you planned it to, right?
I'm just going to go back to steps when it used to work.
Okay.
I think they should work, hopefully.
Let's see.
It did not.
Did you remove a...
Oh,
You restart it?
I did. It's
Are you on Bailey's Wi-Fi?
this. I don't know.
I love this. This is like group debugging.
Is this a Microsoft service from 20?
Easy.
That would scare me a little. What's going on?
I have no idea.
You have no idea. That's good.
You got 12 minutes. You can do it.
Come on.
I'm just gonna
What's the problem?
very good question.
Did it build to the wrong directory?
Yeah, maybe.
I had answers.
Okay. So the composed is in P3 composed. Are you pointing to that one?
Yep,
Are you sure?
I am.
Oh! I was so hopeful.
I
Me
was
as well.
I don't know
Oh,
what.
it's blowing chunks in the back end.
Is the input file wrong?
Yeah, I'm just gonna nuke everything.
We can make this interactive. Everybody just yell their thoughts.
Somebody push a change.
How many people believe this ran? Pretty much everybody. So like put a
Pretty much.
group in there that seems unsure. So like 80% think this did run at one time.
I have no idea.
Just check the input file that you're sending there.
That should.
Are you?
Let me go back.
Yeah, that works.
Even though we are
Okay.
going through the middleware.
Okay, that works. So the business logic works, right?
Yeah. Or maybe is it because I passed the header? I know what the error was because I didn't pass data binary.
It's
And
a
it was trying
error
to pass it
40.
as string.
Error 40. There you go.
If this works, you're going to get applause.
Woohoo!
Yep. So there we can see this was all my fault, not the code's fault. So I should have passed it as binary data. And now when we do that, we can see, depending on if the header is set and we pass in the compressed data, we get back the proper response. And even if the previous request where I sent the data without compression, we could see that we got the data back, how we expected it. And we can also do, if I do accept encoding, it should, it will first complain, or curl will tell me it's binary data that we are getting back because we are getting compressed data back. And then when I add the compressed flag, we can see we get the data back.
Oh.
So how this works is basically how the things are wired together is the compression middleware sits on top of the business logic. The business logic is completely unaware that there are other components doing things before it. So the logic does not change at all. So we can keep stacking multiple middlewares. And based on the headers, the compression middleware takes care of what needs to be done, compression and decompression.
All right. So key takeaways. First one is you did a good recovery from messing up the demo. Thanks for that. Otherwise, you would have had a bad evening. No, key takeaway is obviously we could do component composition with WASIP3, and we had access to async I/O. However, we were limited to one component doing I/O at a single point in time. So with WASIp3, concurrency being like the major concept, so to say, and that also includes the new async function ABI, and we got the generic future and stream types in WIT, allowing us to streamline how we can design contracts in an async way. So that's all we got. The idea was to spend 10 minutes, so we had to debug a little.
Yeah.
But well, it's always great to see how others debug and recognize that the error is in front of the screen. So with that, you can find the source code on GitHub, obviously. And if you have any question, don't hesitate, just ask. Or find us at the Fermyon booth, which is 442. Thanks for your attention. Yeah, I can give you this one.
No worries.
Yep.
How much overhead is there calling Rust functions or from the Rust component, a function in the Rust component from the Python component in WASM, especially compared to native?
I have not really benchmarked it, but I think Luke's talk was indicative of how much overhead there would be because we are just passing in streams directly. I'm not really sure of the real-world numbers because.
So are you talking about like the overhead from once the Python component is actually running, just the invocation to the Rust?
Well, okay, I'm not very into the WASM environment. In my experience, when you call from one language runtime to another language runtime, of course, Rust doesn't have a runtime, but from one language to another, there's overhead. There are translations that need to happen. But since there's already some standardization happening as is WASM, I'm curious how much overhead is there in this world.
Well, so in this case, the interesting thing is that both these components, right, the modules that are talking to each other, are actually in the same language when they execute. So they're in, that's WASM when it's actually on the disk, and that gets compiled into native. So it executes as native, even though it's inside a sandbox and so forth. So the overhead between the two modules, let's say, at the root of a component, the overhead is at the level of WASM across WASM instance. And that's highly optimized. So I don't know what the actual overhead is. I don't know what the numbers would be. But the interesting thing is you're not thinking about doing FFI, for example, from Python to Rust, because that's already gone by the time this executes. And so the system that's executing here between instances is actually built specifically to optimize the communication of the call at the level of WIT and the canonical ABI underneath. So it's pretty fast.
Say same process in nanoseconds.
Yeah, it's okay. I'll say same process in nanoseconds because somebody else has been paying a really close attention. I do remember that when we had a kind of a component plumbers camp like a year ago, when some of this first inter-component calling benchmarking was done, I remember the number that Alex had put up for this was just the first kind of rough draft that was doing. It was something like 20 nanoseconds at that time, and that was the first bit of work that was being done across that boundary. And I'm sure that now Bailey is closer to correct here. So that's how to think about it. It's not from language runtime in the native sense that we're used to thinking about. It's actually built specifically to do these transitions in the most optimized form. Other questions? Or I'll wrap up. Okay, thanks a ton.
Cool, thanks.
Thank you.